Okay. So today our topic is guys OSI model. OSI stands for Open System Interconnection. Okay. OSI stands for guys Open System Interconnection. Now the thing is, what is OSI model and why we need any types of model? The first thing, before OSI model, what was the problem? Before OSI model, there was one problem. And to solve this problem, we need one standardized platform that is called OSI model. Again, I am telling, before OSI model, there was a problem. To solve this problem, we need one standard platform. Getting my point? And OSI model provide us that standard platform. So that is the use of OSI model. Getting my point, everyone? Now, try to understand what is the problem. The problem was, guys, let's suppose this is the Dell machine and this is the Apple machine. The problem was different vendor device cannot communicate with each other. Different vendor device cannot communicate with each other. Even if they wants to communicate with each other, the lots of investment is there. Getting my point? Everyone, let's suppose right now I am using my Dell laptop and you are using the HP laptop. We cannot communicate with each other. Getting my point? Why? Because both devices cannot communicate with each other because we do not have any standard platform where everything will go. Getting my point? So that's the reason that was the problem. That was the problem. Are you getting my point, everyone? To solve these type of problem, what we need? Exactly, we need one standard platform where every manufacturer can make their device, as well as if there are any protocols, any protocol. So if anyone is developing any protocol, they can make sure or take the reference from the OSI model. Getting my point? So that is the use of OSI model. Clear, everyone? I hope you guys understand what was the problem and why we need OSI model. Clear, everyone? Are tell me? Clear, na?
Yes, sir.
So OSI model is sometimes known as reference model also. And this is the interview question. If anyone asks you why OSI model is called reference model, what will be your answer? You can say OSI model is called reference model because every vendor will develop their device, or anyone can develop any protocol by taking reference of OSI model. Getting my point? So basically that is the use of OSI model, and that's why OSI model is known as reference model. Clear, everyone? I hope you guys understand. Tell me. Clear?
Yes, sir.
Yes, sir.
OSI model is important because it helps different device and technology from different manufacturer communicate with each other. Same I told you. OSI model provide a universal set of rule, or you can say it provide us a standard platform or guideline every device or every organization should follow. Clear, everyone? Understand? Now,
Yes.
what was the history of OSI model? OSI model was developed around 1970 or 80s. And the main thing, it was developed by ISO. ISO means International Organization of Standardization. What is International Organization for Standardization? Clear, everyone? And officially it was published in 1984. So that is the short history of OSI model. Now next thing, OSI model is also known as, guys, layered approach model. This is also interview type question. If anyone asks you why OSI model is called layered approach model, you can say OSI model is called layered approach model because in OSI, things is divided into layers. In OSI model, things is divided into layers and every layer support each other. Getting my point? So that's the reason OSI model is known as layered approach model. In OSI model, there are how many layers, guys? 7 layers. First one is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So these are the layers in OSI model. Clear, everyone? Tell me. Understand?
Yes.
So guys, you have to remember this one, the layers. Now, after this, let's start our layer number 7, that is called application layer, guys. See, for your information, I just want to tell you these things. As a network engineer, we never work on this layer, and this layer. These 3 layers are useless for us. Getting my point, everyone? As a network engineer, your main focus will be there. Clear? Everyone, understand?
Yes.
Tell me.
Yes, sir.
Understand now? These 3 layers are called software-based layer. So these 3 layer is taken care by developers, not network engineer. Now, but I already written some points about the application layer, which is helpful for you guys. Application layer is also known as end-to-end layer. It means, guys, application layer is, you can understand like this, application layer provides the user interface to end user. For example, I am the end user. Let's suppose I open any application like Facebook. So when I open the Facebook, all the options are visible to me, in front of me, yes or no, everyone? Right, na? Every option
Yes.
and everything will be visible in front of me. It means this is called user interface. That is called user interface. So that's the reason. Please remember this thing. Application layer provides the user interface. Clear, everyone? Understand? Tell me.
Yes, sir.
It's responsible for providing the network services directly to the user. Why? Because it provides directly to the user interface. Clear? Now, apart from this, what you have to remember, basically application layer provides some services. At application layer, provide some services. What are those services? You have to remember. Guys, first services application layer provides, that is called FTP or TFTP. FTP means file transfer protocol. What? File transfer protocol. Application layer provides these type of services. And what is the use of FTP, guys? By the help of FTP, you can send and receive the files or data. Getting my point, everyone? Tell me. What is FTP? File transfer protocol. And application layer provides these type of services, and by the help of FTP or TFTP, we can send and receive the files or data. Next services application layer provides, that is called SMTP. SMTP means simple mail transfer protocol. Guys, we are able to send the mail, receive the email, right? Everyone, because of the SMTP. Why? Because of the SMTP. Application layer provide HTTP and HTTPS services also. I hope you guys are already aware about it. Whenever you are searching anything, you see na there is a HTTP or HTTPS. Yes or no?
Yes,
Everyone.
websites.
Yes, na? What is the use of HTTP and HTTPS? By the help of HTTP and HTTPS, you can securely access the website. Yes or no? Everyone.
Yes.
Yes. Next, application layer provides the telnet and SSH. I hope someone is aware about the telnet and SSH. What is telnet and SSH? By the help of telnet and SSH, you can take the remote services or remote access of any device. Yes or no? Let's suppose right now I am working from home. I can SSH any device which is present in my office. Yes or no? Everyone.
Yes.
Tell me. Yes, na? Yes, I can access any machine which is present in my office. Tell me. Understand?
I understand.
Yes, sir.
Okay. Next one is, guys, SNMP. Simple Network Management Protocol. So what is the use of SNMP? By the help of SNMP protocol, what we can do? We can manage our network device remotely, guys. For example, routers, switches, servers, we can manage these things remotely. Getting my point? So these are the services application layer providers. Clear? Everyone, tell me.
So we can manage also. I thought
Sorry,
only
we
we can
can.
only monitor. We can manage also devices through SNMP.
Yes, we can manage also. We can configure the device, na? Remotely, we can configure the device. Getting my point? So basically, guys, so these are the thing I already mentioned here in application layer. I think these are the important thing. So you guys can remember these things. And I already mentioned here one table. These table maybe right now you guys will not understand because you guys don't know what is TCP and UDP, what is port number. Okay, na? But right now just read this. Once I complete the layer number 4, then after you guys will understand like this one. Okay. But for your reference, you guys can remember HTTP, HTTPS, FTP, DNS, DHCP, Telnet, SSH. So guys, these are the services present on which layer? Application layer. Which layer, guys? Application layer. For example, HTTP. And these are the thing. These are the thing related to the layer number 4. That is called transport layer. Tell me, understand everyone? Port number and TCP, UDP, we will discuss at layer number 4. Clear? But
Yes.
why these things I already mentioned here, so you guys can remember HTTP use port number 80 and TCP protocol. HTTPS use port number 443 and use TCP. DHCP use 67 port number and 68 port number and it use UDP. Okay, so I already mentioned this table for your reference, so you guys can remember this one only. Clear? Everyone?
Yes.
Okay. The next layer is, guys, presentation layer. Presentation layer means what? Presentation layer means just present the thing. Presentation layer means present the thing. For example, this is me and you guys are, right now you guys are listening me. For example, let's suppose right now I am telling something in Marathi. Maybe maximum guys are not able to understand what I am telling. Getting my point? Yes or no? Everyone. Tell me. Yes,
Yes,
or no?
sir.
Yes. Why? Because see, whatever I am telling, I'm not able to present in the better way in front of you. Getting my point? Everyone. Tell me. That is the problem. So that's the reason you guys are not able to understand. Are you getting my point? Everyone. Similarly, similar kind of thing in a network. Similar kind of thing happening in a network. For example, let's suppose you are searching anything on the web. The data will generate at the application layer. Yes or no? Everyone. Yes. So whatever the data will generate, maybe at application layer. At application layer, whatever the data will generate. Let's suppose the encoding scheme, or you can say the language is different. But let's suppose network do not understand these type of thing. Is it possible to communicate? No. Are you getting my point, everyone? Yes or no?
Yes, sir.
Again, I am telling, for example, you are my student and you guys, and I am telling whatever I am telling in Marathi. but you guys are not able to understand what I am trying to say. So what is the solution? Solution is we need to check any standard language. We need to check any standard language by which I as well as you guys both are comfortable. Yes or no, everyone? Are tell me. Yes, na?
Yes.
That is the solution. Similarly, in a network, let's suppose at application layer, whatever you are searching, let's suppose the encoding language is, let's suppose this is the language, this is the code. You guys can, if you guys need more detail, you guys can Google it about it. This is the language, ASCII or EBCDIC. These are the language. Okay, so let's suppose whatever you are searching on the web or application layer, the language is this one, but your network is not able to understand this one. So it means we need any standard language by which your application layer as well as our network both are comfortable. Yes or no, everyone? Tell me. Yes, na?
Yep.
Yes.
So to solve these type of problem, who is there? Presentation layer. So please remember this one. The use of presentation layer is the main function of presentation layer is to present the data, or you can say to convert the data in a standard format where network can easily understand. Getting my point, everyone? Tell me. Tell me. Yes or no? Okay. So see here, the presentation layer is responsible for translating. Presentation layer is responsible for translating between the format used by application and format required for translation over the network. I hope you guys understand the same thing I told you. Yes or no, everyone? For example, if an application layer use different encoding scheme like ASCII or EBCDIC, it means your complete network is not able to understand this one. This is scheme. So what presentation layer will do? Presentation layer will convert this into standard format. Presentation layer will convert this into standard format. So whole network, whole layer will understand it. Getting my point, everyone? Yes or no? Tell me.
Yes, sir.
Yes, sir.
So this is the first function of presentation layer. Second function of presentation layer is it also provide the encryption and decryption. It also handle encryption and decryption. In the first class, I think I already guys told you about the encryption and decryption. Yes or no?
Yes.
Tell me. Yes, na? So the second function of presentation layer is it provide encryption and decryption. It means, let's suppose this is me, this is you, let's suppose this is internet, whatever I am sending, let's suppose I am sending a message, I love you. What presentation layer will do? First of all, presentation layer will convert this into standard format. Yes or no? Tell me yes or no, everyone? Yes, na? After this, whatever I am sending, this is called plain text, right? Presentation layer convert into encrypted text, like suppose hash star B C A, like this. So this is called encrypted text. Are you getting my point, everyone? So when this encrypted text will reach on destination, there is also presentation layer. And here what presentation layer will do? Presentation layer will decrypt it. Here at sender end, your data or your message will encrypted, and at receiver end, your data will decrypted. And who is handling these things? Presentation layer. Clear, everyone? I hope you guys understand. Are you tell me?
Yes, sir.
Yes, sir.
So I told you right now there are two main functions of presentation layer. First one is translation and second one is encryption and decryption. Clear na? And by the help of encryption and decryption, what we are doing, we can exchange our data securely, or we can exchange our sensitive information over the network or over the internet securely because of the encryption and decryption. Clear, everyone? Tell me. Understand?
Yes, sir.
Now the third thing in presentation layer is providing, that is called compress the data and decompress the data. Let's suppose whatever you are trying to send over the network, let's suppose from application layer you got the data and the size of that data is more. The size of that data is, guys, more. Getting my point? And let's suppose if you send the complete this data over the network, what will be the challenges you guys will face? You guys will face the challenges of related to the speed, bandwidth, like this. Yes or no? For example, let's suppose I am using my Wi-Fi in my home, and let's suppose I am downloading one movie that is 3 GB movie. And at the same time, if other members are using same Wi-Fi, maybe they guys will face some bandwidth and speed issues. Yes or no? Everyone, tell me. Yes, now it is happening basically. Tell me, yes or no? Everyone.
Yes, sir.
Guys, are you guys sleeping? Rahul, Tano,
No, sir.
Lakshman.
No, sir. No, sir.
No, yes, sir. It's fine.
Okay. So what I'm trying to say, let's suppose if I start downloading any movie that is 3 GB, 4 GB, and with the same Wi-Fi, if another member is connected, so definitely they will face the bandwidth or speed issues. Why? Because right now I am consuming more and more bandwidth. Yes or no? Everyone. Yes, na?
Yes.
So to
Yes.
solve this type of problem, there is a called presentation layer. Presentation layer, let's suppose if there is a data, the size of that data is big, so presentation layer will compress this data. What? Compress this data. Getting my point? Then send over the link. And when this data will reach at your end, you can, what you can? Decompress it. Getting my point? So that is the use of presentation layer. So by the help of compress and decompress, you can save the bandwidth and speed of your network. Getting my point, everyone?
Yes,
So
sir.
right now I told you there are three main use of presentation layer. First one is, guys, translation. Second one is, guys, encryption and decryption. And third one is compress and decompress. Now the next layer is called session layer. Session means what? Session means what? What you guys are understand by session? Let's suppose.
Period of the connection.
Yes, exactly. For example, guys, let's suppose right now on Google, I write something. Let's suppose I write facebook.com. It means right now my Google application or browser is making connection with the Facebook server. Yes or no, everyone?
Yes.
Tell me. Yes, na? It means whatever, let's suppose you are searching, you guys are getting response in this tab, in the tab which you are searching anything. Yes or no, everyone?
Yes.
Tell me. See, this is the best example. Try to understand. Let's suppose this is my Google Chrome, and this is my tab number 1, this is my tab number 2, and this is my tab number 3. Let's suppose in this tab I open Facebook, and in this tab I open Instagram, and in this tab I open Twitter. So let's suppose whatever I am searching here in Facebook, so I will get every response in this tab. Yes or no, everyone? Tell me.
Yes.
Is it possible? Let's suppose in this tab, in tab number 1, I am searching the content which is related to the Facebook, and result I am getting in Instagram tab. Is it possible? No, na? Everyone.
No.
It is not possible. Why? Because here, by this tab, the connection is already established with the Facebook server. Getting my point, everyone? And whatever you are searching in related to the Instagram, this tab is already make the session with the Instagram server. Getting my point, everyone?
Yes.
But who is responsible for making these type of connections or session layer? Who is responsible, guys? Session layer. Understand, everyone? Are tell me, clear?
Yes, sir.
And one more thing. This is interview related question. I do not mention here, but you guys can remember. For every session, there is a session ID. For every session, there is a session ID. If there will be a not session ID, then you guys will face the challenges. Challenges will what? Facebook related thing you guys will get in Instagram, and Instagram related thing you guys will get in the Twitter tab. So it means this is the session number 1, this is the session number 2, and this is the session number 3. Every session is separated by session ID. Getting my point, everyone?
Yes, sir.
Every session is separated by session ID. Are you tell me? Understand, everyone?
Yes,
So
sir.
this is all about session layer. Now, next is, and this is very, very important, that is called transport layer. And that is called layer number 4. What is transport layer? Clear, everyone? The first thing what you have to remember, the main use of transport layer is it provide end-to-end communication. The first thing what you guys you need to remember, transport layer provide us end-to-end communication. Clear, everyone? Now, the next is basically transport layer provide us some special thing, or you can say transport layer has some special function. What is the first function is, guys, segmentation and sequencing. Segmentation and sequencing. What do you mean by segmentation and sequencing? Anyone? Any idea?
Breaking
It will-
apart and giving number. So which one is first, which one is second? Like we are downloading movie, 1 GB movie, it is getting downloaded like 1 MB, 2 MB, 1 MB, 2 MB, time by time.
Yes.
So after we download full movie, it will be a one piece only.
Yes. Guys, try to understand. For example, let's suppose this is any server. Let's suppose this is any FTP server, and this is you, and you are downloading something here. Let's suppose this is the link. Through this link, see the scenario. Let's suppose if this FTP server and you are downloading, let's suppose 1 GB data. Let's suppose you are downloading any file and the size of that file is 1 GB. If this FTP server will forward or send complete 1 GB data to the at a same time, what will be the problem? Problem is, let's suppose if there is anything happening here on this link, then complete 1 GB data will drop. Yes or no, everyone? Tell me.
Yes, sir.
Yes,
Yes,
na?
sir. Yes, sir.
So to avoid these, even you guys can see, I think whenever you are downloading anything, and let's suppose your suddenly internet goes down, then download is stop, na? And when internet goes up, you click na relaunch or this type of thing. You there is an option, right, na? So downloading is start, where downloading is stop. Yes or no? Downloading start from where downloading was stop. Yes or no, everyone?
Yes.
Yes, sir.
Yes, na? So to see here, what is the use of segmentation and sequencing? Let's suppose this is the sender, this is the receiver. This sender got the data, let's suppose, from the application layer. And the size of this data is, let's suppose, high. And if this sender send the complete data at the same time over the link, and let's suppose if on this link there is a congestion, on this link there is some congestion. The reason is anything ABC. But let's suppose there is a congestion, and if the sender is sending the complete data at the same time, then your complete data will drop at the same time. Yes or no, everyone? Your complete data will
Yes.
drop at the same and even you guys will occupy or use the lots of bandwidth here on the link. So to avoid these things, there is a concept of segmentation and sequencing. Segmentation means nothing. Segmentation means whatever you are sending, the data will divided into small parts. The data will divided into small parts, and each small parts is known as segment. Each small parts is known as segment. Getting my point? For example, this is the sender, this is the receiver. This sender is sending one message, I love you so much. This is the data. Now, what segmentation will do, guys? This segmentation will divide this data into smaller segment. Like this one, love you so, and this is called what? Segment. This is called segment. Getting my point? Everyone, tell me.
Yes.
So at transport layer, your data will be segmented. At transport layer, your data will be segmented, and each small parts is known as segment. Again, one more thing. Let's suppose these are the segment, and this sender is sending all the segment to the receiver. Please remember this one. This is not mandatory. Receiver receive all the data in a sequential order. No, this is not necessary. Are you getting my point, everyone? What I'm trying to say? Let's suppose sender is sending I love you so much, but is it possible receiver receive first much, then you, then I, like this? This is possible. Getting my point? But the problem is how receiver make these data in a correct order. Now there is a concept that is called
Sequencing.
sequencing. So to solve these type of things, we have a concept of sequencing. Actually, what sequencing will do, whenever sender send the data and your data is divided into segment, and at the same time, sender provide one sequence number to each segment. For example, sender provide sequence number 001, 002, 003, 004, 005. This type of sequence number. So let's suppose now receiver receive much, then you, then I. Then what receiver will do? Receiver will arrange all the data according to the sequence number. Receiver will arrange the data in a sequential order because of the sequence number. Getting my point, everyone? I hope you guys understand now what is the use of segmentation and what is the use of sequencing. Segmentation means sender send the data in, sender divide the data into a small part, that is called segment. And sequencing means sender provide one sequence number to each segment. So whenever your data will reach at destination end, destination device will rearrange the data according to sequence number. That is the use of segmentation and sequencing. Clear, everyone?
Yes.
Understand?
Yes.
Now, next thing is, guys, error detection. Transport layer checks the error in the data segment during the transmission. If error detected, it can request retransmission of the corrupted segments. This helps ensure that data arrives correctly and without corruption. It means this is the sender, this is the receiver. Everyone please focus here. Let's suppose this sender wants to send the data. Let's suppose this is the data. So whenever sender send the data, I will show you in TCP, there is a header that is called TCP header. See here. I already mentioned here. I hope this is visible to all of you. Are you guys able to see this one?
Yes, checksum.
Checksum. So basically, this is the field. At layer number 4, this is the field. What is the use of this field? See here, everyone. That is the use of error detection. Whenever sender is sending the data, this is the data. Okay. So sender use one algorithm. The name of that algorithm is CRC algorithm. If you want, you guys can read about detail way of CRC algorithm on a Google. You guys will get. But the name of algorithm is CRC algorithm. Are you getting my point, everyone? What sender will do? Sender run this CRC algorithm on this data. Getting my point, everyone? So when sender run the CRC algorithm on data, sender calculate one random value. For example, 000XX. This is the random value sender receive or got when sender run the CRC algorithm on this data. Getting my point, everyone? Yes or no? Tell me.
Yes.
Anyone who do not understand till now? Nabil, understand?
It's fine. Thanks.
I don't understand.
So what I told right now, whenever sender sending the data, sender run the CRC algorithm on the data. And when sender run the CRC algorithm over the data, sender got one random value. Let's suppose this is the value. Then after, sender put this value in checksum field. In the field, guys, what field? Checksum field. Okay. And sender send the data. Now this data will reach on receiver end. What receiver will do? Receiver again run the same CRC algorithm on this data. And receiver also got one random value. Getting my point, everyone? Now receiver match this value with this value. If both value will match, then receiver accept this data. And if this value will not match, receiver denied this data. Getting my point, everyone? Understand? That is called error detection. Getting my point? This field, let's suppose if sender is sending the data, if there is any hacker, and if hacker change the thing in a data, definitely when this data will reach at the receiver end, and when receiver run the CRC algorithm, then definitely the CRC value will be different, na? Yes or no?
Yes.
Yes, na? CRC value will be different. In this case, receiver can easily understand. Definitely there is a modification in this data. There is a modification in this data, and receiver refused to accept it. That is called error detection. The next thing is, guys, flow control. This is the third function layer number 4 provide, that is called flow control. Flow control is nothing. Flow control means, let's suppose whatever I am teaching you right now, right now, and let's suppose I am continue teaching since 3 hours. Maybe after 3 hours you guys will exhaust. Yes or no? Rahul will tell, sir, रहने दो हो गया. Everyone, yes or no?
Yes.
Yes, there is a capacity how much you guys can learn in a single day. Ibn, yes or no?
Yes.
Nabil,
Yes, sir. Yes.
Nabil, let's suppose if I am explaining any topic since 3 or 4 hours, definitely at a point you will exhaust.
Yes.
You will tell, sir, this is enough for today. Yes or no?
Yes.
Yes,
Yes.
definitely. This is the
Yes,
human
yes.
behavior. This is the common thing. Yes. So that's the thing. Let's suppose this is the sender and this is the receiver, and this sender and receiver is connected with like this. And whatever you are sending, you will send through the interface. Yes or no, everyone? Tell me. Whatever sender will send through this interface. Yes or no? And whatever
Yes,
receiver will receive everything on this interface. Yes or no, everyone?
Yes.
Tell me. Yes.
Yes.
Please remember, there is a limited size of this interface. there is limited size of this interface, or you can say there is a limited memory of this interface. And if the sender is sending the data, sending, definitely there will be a time. Then receiver refuse to accept it. Yes or no, everyone? Yes.
Yes.
That is called flow control. So at layer number 4, that is called transport layer. Transport layer also taking care of these things. Transport layer also taking care of these things. See now, the transport layer manage the rate at which data is sent to prevent overwhelming of the receiving device. Otherwise, receiving device will refuse to accept it. Then let's suppose the memory will full. Then definitely how receiver device will receive your data. Getting my point, everyone? Yes or no? Yes.
Yes.
So to adjust the data flow based on the receiver's ability, how much he can process. Getting my point? To adjust the data flow based on receiver ability to accept it or process it. Transport layer manage the efficient communication. Getting my point? And that prevent the loss of data and congestion. Let's suppose the memory is full and the sender is sending the data. Maybe, and what receiver will do? Receiver will refuse to accept it and your data will drop here. Yes or no, everyone? Yes. So to avoid these type of things, transport layer provide the flow control mechanism. That is called flow control. I hope everyone understand flow control. Clear? Everyone?
Yes.
Yes, sir.
So at transport layer, please remember there are 3 important things that is called segmentation and sequencing. Second one is error detection by CRC algorithm, and third one is flow control. Clear, everyone? Tell me.
Yes, sir.
Yes,
Okay.
sir.
Next is, guys, at transport layer, there are 2 different type of protocol. At transport layer, there are 2 different protocol used. The name of that protocol is TCP and UDP. TCP stands for Transmission Control Protocol. What is, guys? TCP means Transmission Control Protocol. Are you clear, everyone? Yes or no?
Yes.
Understand? Okay.
Yes, sir.
Let's discuss something about the TCP. The first point, it use protocol number 6. Right now, just remember it. Protocol number I will show you when I will teach you the next layer, that is called network layer. There I will show you the protocol number. Getting my point? Right now, just understand TCP use protocol number 6. Are you clear, everyone? Yes or no?
Yes.
This is the point number 1 about the TCP. Point number 2 about the TCP, it is a connection oriented protocol, and this is the most VVI thing. In maximum interview, interviewer ask this question: TCP is a connection oriented or not? What will be your answer? Yes, TCP is a connection oriented protocol. Now interviewer will ask why. What will be your answer? Your answer will be TCP is a connection oriented protocol because TCP perform 3-way handshake. Again, I am telling 3-way handshake. Lakshman, 3-way handshake means? Do not think like this. This is me and I have 3 hands. No. 3-way handshake means this is the sender device, this is the receiver device. Everyone, please focus. This is the sender device and this is the receiver device. First of all, sender and receiver establish a secure connection with each other. Then after sender and receiver start sending the data. First of all, let's suppose this is me. and this is you, and I and you both are living, let's suppose near, let's suppose you are my neighbor, but let's suppose if I and you both are not a good neighbor, then how we will exchange the thing? Is it possible? No, na. First of all, we should have the good neighbor. Yes or no? Then after we can exchange the thing. Yes or no, everyone? Yes, na? Similarly, this is the sender and this is the receiver. Please remember this thing. Sender and receiver cannot and do not exchange the data until both sender and receiver establish a proper secure connection. Once the proper secure connection will establish, then after sender and receiver exchange the data over the network. Otherwise, no. And sender and receiver establish a secure connection because of the TCP. Because of the TCP. Because in TCP has three-way handshake. TCP has three-way handshake. For example, see guys, I mention one diagram here. What is this? Try to understand. There are one router and router number 2. There are two router. Yes or no? Everyone, tell me.
Yes.
Yes. See now,
Yes.
on router number 1, I configured one routing protocol that is called BGP, and here I configure BGP. Clear? Everyone. Tell me. BGP is a layer 7 protocol. Okay, na? So if there is a if it is a layer 7 protocol, it means definitely it use layer number 4. Again, I am telling you one thing. Maybe you guys will confuse. Let's suppose whenever I will teach you OSPF, I will teach you EIGRP. You guys will ask the question, sir. You are, let's suppose this is the router and this is the router. On this router, you configure OSPF and OSPF. Is this router establish a secure connection? Then after both router will start sending the data? Answer is no. Guys, when you configure the OSPF and EIGRP, both devices do not establish a TCP connection. Why? The reason is OSPF and EIGRP is a layer 3 protocol and TCP is a layer 4 protocol. Getting my point, everyone? Yes or no? So when you configure the OSPF or EIGRP, your data will start from the layer number 3, na? Yes or no?
Yes.
Yes. So if your data will start from layer number 3, then there is no role of TCP because TCP from layer number 4. If you want to use TCP, you have to use any other routing protocol which works above layer 4. Yes or no? Everyone, tell me.
Yes.
Yes, sir.
On this router 1 and on this router 2, let's suppose I configure BGP and BGP. Guys, BGP is a layer 7 protocol. It means your data start at layer or data, you can say your data start from layer number 7. Yes or no? Tell me. Yes. Layer number 7, hand over your data to layer number 6. Yes or no? Guys, data will encapsulate like this. Please remember this one. Tell me. See. Let's suppose I am using BGP. BGP generate at layer number 7. Layer number 7 hand over this data to layer number 6. Layer number 6 hand over this data to layer number 5. Layer number 5 hand over this data at layer number 4. And at layer number 4 there is a protocol, not TCP or UDP. Yes or no, everyone? Right, na? So before sending to the next layer, first of all, layer number 4 establish a TCP connection, or you can say three-way handshake. Getting my point, everyone? Yes or no? Tell me.
Yes.
Yes.
Sir.
For example, this is the router number 1 and this is the router number 2. Here I configure OSPF. OSPF generate. OSPF is a layer number 3 protocol. It means your data will generate at layer number 3. Layer number 3 hand over to layer number 2 and layer number 2 hand over to layer number 1. Is there any role of TCP here? No. Because your data is already generated at layer number 3. Where is layer number 4? No. because layer number 4 is above. So if you want TCP connection or UDP connection, your data must be generated at above layer number 3. Yes or no? Everyone, tell me.
Yes.
Guys,
No,
Yes.
no.
Sir.
Nabil, understand?
Yeah. Yes.
Exactly. So see guys, what do you mean by three-way handshake? See here. Three-way handshake means if this is the two device, okay? So this device first of all generate the TCP packet, okay? And in TCP packet, please remember, when device is sending the TCP packet, na, in TCP packet there is a flag. There is a flag. There are multiple type of flag. In one flag that is called SYN. SYN means synchronization. SYN means synchronization. Okay. So when this router initiate the TCP packet, SYN flag bit always on. Getting my point, everyone? Understand? And one more thing. When at TCP or at layer number 4, there is two things. Port number. Guys, what is port number? Getting my point? So there will be a source port number and destination port number. There will be a source port number and destination port number. Fine. So please remember there is a one more rule. Guys, this is the advanced thing, but I am just telling you, maybe you guys will understand. So again, I am telling at layer number 4, there is a one concept that is called port number. Understand? Port number, there will be a source port number and destination port number. Clear? So please remember one thing, the device which is initiating the TCP packet, that device use any random TCP port number. And the destination device use the fixed port number. What is fixed port number? Getting my point, everyone? Understand? Again, I am telling. See here. Here on router 1 and router 2, which protocol I am using, guys? BGP. BGP use port number 179. This is fixed. BGP use port number what? 179. So see na, who is initiating the TCP packet? Router 1. So router 1, when router 1 is sending, see na, SYN bit is on or off? On. SYN bit is on. What is the source port number? 11828. This is the random port number. What is the destination port number? 179. Fix. Are you getting my point, everyone? Yes or no?
Yes, sir.
Understand? So,
Yes. Yes, sir.
So router 1 is sending the TCP packet. This TCP packet will reach on R2. What R2 will do? R2 again send the TCP packet. And in this TCP packet, R2 first of all enable the acknowledgement bit. Acknowledgement bit means what? R1 already sent the SYN bit. Yes or no? So it means R2 is telling the acknowledgement of this SYN bit. R2 is sending the acknowledgement of this SYN bit. And after that, R2 is sending its own SYN also. R2 is sending its own SYN. Again, please remember, R2 is sending the two things. Acknowledgement. Acknowledgement of what? Acknowledgement of this SYN. R2 is
I
telling,
receive.
hey bro, I already received your TCP packet. So by the help of this acknowledgement bit, R2 is telling to R1. Getting my point, everyone? Yes or no? And
Yes.
by the help of this SYN, R2 is sending its on SYN. On SYN. What is the source port, destination port? Source port number will be 179 and destination port will be, what is the port number of R1? 11828. Are you getting my point, everyone? Yes or no? So when this TCP packet will reach on R1, what R1 will do? R1 again send one TCP. And in this TCP, R1 send the acknowledgement of R2 SYN. R2 is also sending one SYN message. So R2 is sending, yes bro, I already received your SYN. So this is called TCP three-way handshake. I hope you guys understand, everyone.
Yes, sir.
Yes.
So Before sending any message at layer number 4, establish a TCP connection. Getting my point, everyone? Understand?
Yes, sir.
And TCP connection will establish by the help of three-way handshake. Three-way handshake means one device initiate TCP packet. In this TCP packet, SYN bit will be on. When this packet will reach on destination device again send the TCP. In this TCP destination device, send the acknowledgement bit. Acknowledgement bit means receiver is telling to sender, yes, I receive your SYN, and receiver is sending its own SYN also. When this TCP packet will reach on R1, R1 again send TCP, and by the help of this TCP, R1 is sending the acknowledgement of R2 SYN. That is called three-way handshake. Why? Because both devices exchange how many messages? 3 TCP messages. So that's the reason it is called three-way handshake. Are you clear, everyone? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now, again, there is one interview question. Question is, what do you mean by three-way handshake and four-way handshake? Guys, there is one more thing, four-way handshake. Please remember, when you want to establish a connection, there is a three-way handshake. And when you want to terminate a session, there is called four-way handshake. Understand, everyone? I hope if anyone asks you, you guys can easily answer. Three-way and four-way. Three-way means to establish a connection, we need three-way. And to terminate a session, we need four-way handshake. Are you clear, everyone? Yes or no?
Yes.
Tell me. See now,
Yes, sir.
this is called four-way. Let's suppose this is router number 1 and router number 2. Let's suppose router number 1 wants to terminate a session with R2. What R1 will do? R1 generate one TCP packet. In TCP packet, R1 enable the FIN bit. FIN means finish. FIN means finish.
Finished.
R1 initiate the TCP packet, or in this TCP packet, R1 enable the FIN bit. When this FIN bit receive the R2, R2 again send the TCP, and in this TCP R2 send or R2 enable the acknowledgement bit. It means R2 is telling I receive your FIN. Fine. Now again R2 send another TCP, and in this TCP R2 is telling the what? Guys, there is a mistake. That is called
FIN.
FIN. Clear, everyone? Yes or no? R2 is telling, yes, if you want to terminate, yes, okay, I received, I acknowledge your TCP packet. Now I also wants to terminate, and R2 also send the FIN, and finally this one also send the acknowledgement, and finally this is called four-way handshake, and session will terminate. Are you clear, everyone? Yes or no?
Yes.
I hope you guys understand about the TCP. So these are the thing you guys must need to remember. The first thing, TCP use protocol number 6. Second thing, TCP is a connection oriented protocol. Why? Because what? Because TCP perform the three-way handshake. Are you getting my point, everyone? Yes or no?
Yes.
The third
sir.
thing you guys need to remember about the TCP, TCP is a reliable protocol. This is the third one. Reliable means if you are using TCP, it means for every messages you guys will get the acknowledgement. That is called reliable. Getting my point, everyone? Understand?
Yes.
Tell me yes or no?
Yes, sir.
R1 is sending the TCP, R1 is sending the SYN, but R1 is getting the acknowledgement from R2 for this SYN. Yes or no?
Yes,
And
sir.
R2 is sending its own SYN, then R2 is also getting the acknowledgement from R1. Yes or no? Yes, na? So please remember, if we are using the TCP, we will, for in TCP, you guys will get acknowledgement for each and every messages. Clear, everyone? Yes or no? Understand?
Yes, sir.
Yes, sir.
Now the next one is, guys, UDP. So first thing about the UDP, UDP use protocol number what? 17. Protocol number 17. And this is called connectionless protocol. It means it do not perform the three-way handshake, guys. It do not use the three-way handshake because it is a connection-less protocol. And it is not reliable. It means in case of UDP, we will not get the acknowledgement. For example, let's suppose right now, I and you guys are connected by the WebEx. Yes or no, everyone? Yes, na?
Yes.
Tell me. Yes, na?
Yes, sir.
Yes, sir.
So this is connection oriented or connectionless?
Connectionless, sir.
Yes, this is connectionless, guy. For example, let's suppose whatever I am telling and you miss. Do you get the acknowledgement for it? No. You guys will not get the acknowledgement. Tell me, yes or no? Tell me, yes or no? Yes, na?
Yes.
Yes, sir.
That is called connectionless. We are not performing the three-way handshake here. And this is not the reliable. In case of TCP, for every message, TCP provide you guarantee for every message. Basically, in TCP, you guys will get the acknowledgement for every message. It means TCP provide you guarantee of delivery. But in case of UDP, UDP do not provide you guarantee for delivery. Yes or no, everyone? Yes, na?
Yes,
Let's
sir.
suppose in TCP, if any packet will drop, your receiver send the acknowledgement for the retransmission. One more thing, TCP provide the retransmission also. For example, sender and receiver. Sender is sending I love you. And anyhow, let's suppose there is a congestion on this link and this message, you message drop here. And there is a sequence number 1. This is the sequence number 2. And when this packet will reach on receiver, receiver got only sequence number 1 and 2. Receiver do not find sequence number 3. In this case, receiver sent the retransmission message. And by the help of retransmission message, receiver can request for sequence number 3. And when this packet will reach on sender, sender will send this one again. In this case, what is happening? By the help of TCP, for every messages, TCP provide you a guarantee for delivery. Yes or no?
Yes, sir.
For every messages, TCP is providing you the guarantee. If any packet drop, receiver send the retransmission message. But in case of UDP, drop means drop. UDP means drop means drop. Are you getting my point, everyone? Yes or no? I
Yes,
hope you
Yes,
guys
sir.
understand. Clear, na? So UDP do not provide you the guarantee for delivery. Even in TCP, there is a concept na checksum. If you guys remember, there is a concept of checksum also at presentation layer also, at layer number 4 also. See na, at layer number 4, see na, checksum. Everyone, yes or no?
Yes.
So
Yes.
at layer number 4, if you are using the TCP check the error inside the data. But UDP do not check the error also, guys. UDP do not check the error. Understand? Now the thing, if you remember, I told you here. I told you now when I told you about the layer number 4, then you guys will understand. Let's suppose at application layer, let's suppose you are using HTTP. HTTP use TCP or I told you at layer number 4, there are only these two type of protocol. Yes or no?
Yes.
Guys, these are the layer number 7 protocol. Yes or no? So if these are the layer number 7 protocol, it means it will go at layer number 4 also. Yes or no? Yes. So when
Yes.
these data will go at layer number 4, then at layer number 4 only two things is possible. Either these data use the TCP or UDP. Because at layer number 4, there are two type of protocol. TCP or UDP. Are you understand? Yes or no? Yes, na?
Yes, sir.
Yes.
So if your data is HTTP, then HTTP use which protocol? TCP. If your data is HTTPS, it use TCP. If your data is FTP, it use TCP. If your data is related to the DNS, it use both TCP and UDP. If there is a DHCP, it use UDP. Telnet use TCP. SSH use TCP. I hope now you guys understand. Clear na? Everyone, tell me.
Yes, sir.
Yes, sir.
Yes.
So it depends upon type to type data. Clear? Everyone. Understand na?
Yes.
So see, this is guys TCP header. Whenever you generate any packet na, when let's suppose any packet is generated at layer number 7, then this is the TCP header. TCP header looks like this. TCP header looks like this. See na? What is? I told you na, there are two things, source port number and destination port number. Yes or no? Yes.
Yes.
I told you na, there is a sequence number, acknowledgement number. Are you getting my point? Yes or no? Reserved
sir.
bit, it will always be 0. In flag bit, here you guys will get SYN flag, acknowledgement flag, pin flag. These are the flag here you guys will get. Okay, everyone. Checksum field I already told you. Yes or no? Everyone, tell me. So this is called TCP header. TCP header looks like this. Clear everyone? Yes or no? Tell me.
Yes.
And
Yes.
this is the UDP header. In UDP header, only these are the things. 4 content is there. Source port, destination port, length. Length means this tells us size of the data. Sorry, size of the header. And checksum. Tell me, yes or no? Understand? So these are
Yes.
the thing. These are the header of TCP and this is the header of UDP. Guys, I already mentioned what is the difference between TCP and UDP. So first difference is TCP is a connection oriented, but TCP is a connectionless. I hope you guys understand now. Because TCP provide the three-way handshake, but UDP do not provide the three-way handshake. Yes or no? Everyone, tell me.
Yes.
Yes, na?
Yes.
Guys.
Yes, sir. Yes, sir.
Okay. Second difference is TCP is a reliable protocol, UDP is unreliable protocol. It means TCP provide you the guarantee for delivery, but UDP do not provide you guarantee for delivery. Because in case of TCP, you guys will get acknowledgement for each and every messages. But in case of UDP, you guys will not get acknowledgement. Yes or no? Everyone, tell me.
Yes. Sir.
Yes. Third difference is TCP provide the flow control, but UDP do not provide the flow control. Are you tell me yes or no? Yes. Next
Yes.
is
Sir,
size
what
of
is
the.
windowing?
Sorry.
What is windowing?
Windowing. Windowing is the concept like you can understand like the flow control also. Basically in windowing, it create the space. I will tell you later in a detail way, don't worry. Okay.
Yes, sir.
Next is guys, header length. In TCP, the size of header is how much? 20 byte. But in case of UDP, size of header is how much? 8 byte. Now TCP is slow, UDP is fast. Now again, this is the question. Why TCP is slow and why TCP is fast? I told you each and everything. Who can tell me the answer? TCP is slow, UDP is fast.
Because, sir, it is connection oriented. Make sure every data delivers.
Okay, so first you are telling TCP is a connection oriented, that's the reason. Okay, second, anyone have any
Second-
different answer?
Sir, it
I
makes
want-
sure that every data gets delivered.
Wait, Rahul. I want answer from each and everyone. Anyone have any different
Error
point?
detection.
Error detection.
Yeah.
Okay. No. Anything else?
Flow control. And the size of the header.
Exactly. Size of header. Very good. Anything else? TCP is the reliable. Yes or no? Guys, these are the main reason These are the main reason. First thing, TCP is the connection oriented because TCP establish a connection by the help of three-way handshake. Definitely it takes time. Yes or no, everyone? Yes. Size of the header. If you are using the TCP, the size of the header will be 20 byte. It means over the link, for every TCP session, 20 byte information will exchange. But in case of UDP, only 8 byte. Third one, reliable. It means in case of TCP, you guys will get acknowledgement for each and every messages. But in UDP, you guys will not get the acknowledgement. So basically, these are the three reasons. These are the three reasons by which TCP is the slow and UDP is the fast. Clear? Everyone, tell me.
Yes.
Guys, understand?
Yes.
Yes, sir.
Now the next layer is guys network layer. That is called layer number 3. First thing I tell you about the layer number 3. Layer number 3, which device works? Router. Okay, router works at layer number 3. Clear to all of you? Everyone.
Yes.
Router works at which layer? Layer number 3. Are they clear everyone? Yes or no?
Yes.
Yes.
Okay.
Yes, sir.
So the next is at this layer IP address works. At this address logical address works. That is called IP address. You know na logical address is IP address is called logical address and MAC address is called physical address. Everyone, do you guys understand these 2 points? Everyone. Okay.
Yes, sir.
On the basis of these 2 points, there is a question why router is called layer 3 device. Why router is called layer 3 device? Everyone, please listen my answer very, very carefully. Router is called layer 3 device because router will take every forwarding decision on the basis of logical address that is called IP address. Clear everyone? Do you guys understand? Again,
Yes,
I
sir.
am telling router is called layer 3 device because router will take every forwarding decision on the basis of layer 3 address that is called IP address. Clear? Are you tell me? Yes, no?
Yes.
That is the reason router is called a layer 3 device. Now the next thing is this layer is responsible for routing the data from source to destination across the different network. I told you in the first or second class, at network layer, which device works? Router. And by the help of router, you can send the data from one network to another network. It means router help to exchange the data between LAN. Yes or no? Everyone. Yes, na?
Yes.
Tell me. Router can route the data between the LAN, or you can say router can route the data between different networks. Now, this layer determines the best path to data travel. Yes. Network layer also provide you the best path selection. Basically, this is the router. Router maintain one table. What is the name of that table, guys? Routing table.
Okay.
In routing table, there is information about network ID or IP address. Yes or no? And router take the forwarding decision on the basis of network ID or IP address. Yes or no? Everyone. Yes, na?
Yes.
Can you tell me? Yes, na? So similarly, you can say router will choose the best path according to the IP address. So it means network layer also help us to provide the best path. This one I already told you. What is this? Fragmentation. Fragmentation is nothing. This is exactly same like segmentation. What do you mean by segmentation? Segmentation is the process by which your data is divided into a smaller size. That is called segment. Yes or no? Everyone, tell me.
Yes.
Yes,
Yes.
sir.
Everyone. What is segmentation?
Yeah.
Segmentation is the process by which our data is divided into a small part and each part is called segment. Yes or no?
Yes.
Yes. And segmentation will happen at which layer?
Layer 4.
Layer number 4. Same fragmentation. What is fragmentation? Fragmentation is the process by which your data is divided into a small part and each part is called fragment. And this will happen at layer number 3. Clear, everyone? Tell me.
Oh,
I hope now you guys
Yes, sir.
able to understand segmentation and fragmentation. Segmentation means also divide the data into a smaller part. Fragmentation is also divide the data into a smaller part.
oh,
Okay. In case of segmentation, your smaller part is known as segment. In case of fragmentation, your smaller part is known as fragment. Segmentation perform at which layer? Layer number 4. Segmentation perform at which layer? Layer number 3. Tell me, everyone, understand yes or no?
yes, sir.
Guys,
So the segmentation are encapsulated in fragmentation.
sorry.
So the segment are encapsulated in fragments.
Segment are encapsulated into fragment.
In layer 3.
No. Guys, see here one thing. Let's suppose this is the layer number 7. Let's suppose this is the data. Okay. This data hand over to layer number 6. Yes or no? Yes. At layer number 6, at layer number 5. This is called what? Data. Tell me yes or no. And these are software parts. So as a network engineer, we don't care about it. Now your data will hand over to layer number 4. Yes or no, everyone? Tell me.
Yes.
Your complete data
Yes.
will divide it into a small part. Okay. Now let's suppose I'm discussing about one part. At one part, let's suppose this is the data layer number 4 receive. Yes or no? From layer number 5. Layer number 5 hand over this data to layer number 4. Na? Yes or no? Yes.
Yes,
And
sir.
after this, what layer number 4 will do? Layer number 4 add either TCP or UDP, because at layer number 4 either there are two protocols, na TCP or UDP. Yes or no?
Yes.
Yes. For example, this is the HTTP data, and HTTP use TCP or UDP? TCP. So at layer number 4, TCP data will included there. Yes or no? Tell me yes or no. Yes, na?
Yes, sir.
Yes. Okay. And the complete thing is known as what? Please remember, at layer number 4, the complete thing is known as segment. Tell me yes or no. Yes, na?
Yes.
This
sir.
is the one segment. Okay, na? There are multiple segments because at layer number 4, this data is already divided into multiple segment. Yes or no? Everyone.
Yes.
Yes,
Yes,
sir.
na? This is the
Yes.
single
Yes.
segment which we are discussing here. Nabil, understand? So at layer number 4,
Yes.
this
Mhm.
is the data layer number 4 received from L5. And layer number 4 include either TCP or UDP. Let's suppose TCP. Now, overall data is known as what? Segment. So please remember, this is also very important question. At layer number 4, data is known as segment.
Segments.
Now, layer number 4 hand over this to layer number
3.
3. Layer number 3. So layer number 3 receive what? Segment? Yes or no? Layer
Yes.
number 4 hand over this segment to layer number 3, na? Yes or no?
Yes.
Guys, yes, na?
Yes.
Yes.
Yes. Okay. Now, there is at layer number 3, there is also one header. What is the name of that header? IP header. So this is IP header. And please remember, at layer number 3, complete data is known as packet. At layer number 3, complete data is known as packet. See, na, at this layer, data is called packet.
Right.
Understand, everyone? Tell me.
Yes,
Guys. So I hope you guys understand segment and packet. At layer number 4, your complete data is known as segment. And at layer number 3, your complete
Packet.
data is known as packet.
Packet.
And again, layer number 3 hand over this packet to layer number 2.
Two.
Yes or no? Tell me.
Yes, sir.
At layer number 2. So layer number 2 receive packet. And layer number 2 again add header, na everyone? Yes or no? At layer number 2, there is a header called Ethernet header. And please remember, at layer number 2, the complete data is known as frame. At layer number 2, your complete data is known as frame. Understand? So I told you 3 things: segment, packet, and frame. Layer number 4, data is called segment. Layer number 3, data is known as packet. At layer number 2, data is known as frame. Are you clear, everyone? Yes or no?
Yes, sir.
Understand? Okay.
Yeah.
At layer number 3, there is IP address. Yes or no? At layer number 3, what is we are using IP address? Yes or no? Yes, na?
Yes, sir.
Tell me. So
Yes.
if we are using the IP address, then there is a IP protocol, and that's why at layer number 3 we have a IP header. What is IP header? Tell me. Understand, everyone? Yes or no? Tell me. Yes or no? Understand?
Yes,
Yes.
sir.
In IP header, Sina, these are the things, these are the content you guys will get the IP header. Source address means source IP address. Destination address means destination IP address. Guys, see here protocol number. I told you, na, TCP use protocol number 6, UDP use protocol number 17.
17.
Basically, protocol number tells us about what are the protocol. What are the protocol used above this layer? It means this is the layer number 3. Above this layer, that is called layer number 4. Tell me yes or no? Yes, na?
Yes, sir.
So above layer number 3, there is a layer 4. And at layer number 4, there are only 2 protocol, either TCP or UDP. So either you will get here 6 or
17.
are you getting my point, everyone? Understand?
Yes, sir.
This is the version. Version means
Hmm.
IPv4 or IPv6. Are you getting my point, everyone? So these are the things. Header checksum also. It means this layer also check the error. Getting my point, everyone? So these are the things you guys will get in the IP header. There is one more thing, guys. Time to live. That is called TTL. Basically, the one use of TTL is it is used to avoid the loop. What is the use of TTL? It is used to avoid the loop. Are you getting my point, everyone? Yes or no?
Yes, sir.
Understand? See what I am trying to say. For example, this is router number 1, router number 2, router number 3, and router number 4. Let's suppose these routers are connected like this. Let's suppose there is a one PC1 and there is one PC2. And let's suppose this PC generate any packet. Any packet. Not connect PC here because concept will be different then. Let's suppose these are the thing. Let's suppose this router generate any broadcast packet. Broadcast packet. For example, here. It means this router also receive this packet and this router also receive this packet. This router also forward this packet here. This router also forward this packet here. It means this router receive the same packet on this interface as well as this interface. Yes or no, everyone? Tell me.
Yes, sir.
Yes, na, everyone? Yes or no? Yes?
Yes, sir.
Now, what this router will do? Let's suppose this router receive on this interface first. So what this router will do? This router again forward this packet through this interface. Again, this router forward this through here. Let's suppose after some time this router receive the same packet here. What this router will do? This router forward this packet again here. Again here. See na? What is happening here? Packet is moving like this. It means it create what? Loop. What it create? Loop, na, everyone? Yes or no? This
Yes.
is called loop. Loop means if same packet router receive on two interface, it means that is called loop. Yes or no? Array, this router received the same packet on this interface as well as on this interface. Right? Again, this router forward this packet here. It means this router already received the same packet on this interface. And now this router receiving the same packet on this interface. And this is called what? Loop. Are you getting my point, everyone? Yes or no? So to avoid these type of loop, we have a concept of TTL. By default, TTL value is 255. 255. And there is a rule. When any packet, please remember this rule. When any packet cross any layer 3 device, its TTL value will decremented by 1. Again, I am telling, when any packet cross layer 3 device, its TTL value will decremented by 1. See here what will happen. Router 1, router 2, router 3, router 4. Let's suppose loop created here. So it means when this packet, when this router sent the packet, by default, what was the TTL value? 255. Yes or no? Yes,
Yes, sir.
this packet will reach here. Now this router is forwarding. Then when this router is forwarding, it means TTL value will decremented by 1. It means now TTL value will be 254 here.
So,
This packet will reach here. Again, this router forward here. Now TTL value will 253. Again here 252. Again packet moving. When TTL value will 0, packet will.
oh,
So by this way, we can avoid the loop. And if there is no TTL value, then packet will continuously moving. Are you getting my point, everyone? Yes or no?
yes.
Yes, sir.
So that is the use of TTL value. Now the next layer is, guys, data link layer. Data link layer is also known as layer number 2. First thing I already told you. At data link layer, your data is known as frame. Second thing, which device works at layer number 2? Switch. Which device? Tell me. Switch.
Switch.
Second point, at this layer, which address works? Physical address. That is called MAC address.
My goodness.
Now again question, why switch is called layer number 2 device? Who can tell me the answer?
Because we
Switch
forward
Yes.
the
Yes,
frame
yes.
based on MAC address. Sorry.
Exactly. Switch is called a layer 2 device because switch will take every forwarding decision on the basis of physical address, that is called MAC address.
My goodness.
Clear, everyone? Now third thing, that data link layer also check the error. I told you, by the help of one algorithm. What is the name of that algorithm? CRC algorithm. Cyclic redundancy check. Now at data link layer, there is one header. What is the name of that header? Ethernet header. What is Ethernet header? Size of this header is 14 byte. So see now, these are the content in this header. Understand, everyone? This is the destination address. It means destination MAC address. This is source MAC address. This is total size of this header. This is the data, actual data. This is called checksum value. Are you understand, everyone? Yes or no?
Yes, sir.
Yes, sir.
Now, when data will reach on layer number 2 hand over this data to layer number 1, that is called physical layer. That is called physical layer. Please remember only one thing about the physical layer. What physical layer number 1 will do? Physical layer receive frame. Yes or no? Because at layer number 2 data is known as frame, na? Yes or no?
Yes.
At layer number 2 data is known as frame. Now data link layer hand over this frame to layer number 1, that is called physical layer. Now the role of physical layer is physical layer converts your frame or data into binary and forward your data through medium or by link. Getting my point, everyone? I hope you guys understand. Can you tell me?
Yes, sir.
Clear? So again, I am telling guys what is happening. Please understand. Let's suppose any HTTP data generate here. This generate at layer number 7. Yes or no? Everyone. It hand over to layer number 6. It hand over to layer number 5. That is called data. Are yes or no?
Yes, sir.
Layer number 5 hand over this data to layer number 4. So layer number 4 receive data
Segment.
as well as layer number 4 add TCP, either TCP or UDP. In HTTP use TCP or UDP? TCP. Are yes or no? Yes, na
Yes.
everyone. And in TCP there is a source port number and destination port number. Yes or no, everyone? Are tell me.
Yes.
Stina, I already told you here. If you
Yes.
remember, for HTTP, what is the port number?
Yes.
80. Are tell me yes or no? Are
Yes, sir.
HTTP port number 80. Now, at layer number 4, this is known as segment. Are tell me yes or no, everyone? Yes,
Yes,
na?
sir.
Now, it hand over to layer number 3. At layer number 3 receive this segment. What layer number 3 will do? Layer number 3
Okay.
add the IP header. Yes or no, everyone? In IP
Yes.
header, there are multiple things, but it use IP header. In IP header, there is a call protocol number. Yes or no? Are tell me yes or no? Yes, na?
Yes.
So,
Yes.
this layer number 3 check. This segment belongs to TCP or UDP. Then it will find this belongs to TCP. And for TCP protocol number is 6. Are yes or no? Yes, na?
Yes, sir.
And at layer number 3, this is called packet. It will hand over to layer number 2. At layer number 2 receive this packet. What layer number 2 will do? Layer number 2 add Ethernet header. Yes or no? Are Ethernet header. In Ethernet header, it add source MAC address, destination MAC address like this. Now layer number 2 hand over this to layer number 1. What layer number 1 will do? Layer number 1 convert. Sorry.
Right.
At layer number 2, this is called frame. Right na? So layer number 1 receive this frame. Yes or no? Yes. So layer number 1 convert this frame into binary language in bits and forward this bits to the link. Getting my point, everyone? I hope you guys understand.
Yes, sir.
This is called OSI model. Now, the next model is, guys, TCP IP model. TCP IP model. I already mentioned one thing here. Please remember, what is the difference between TCP IP model? Please read this one. Mostly used for teaching and theoretical purpose. OSI model generally we are using for the teaching and theoretical purpose, or you can say OSI model generally we are using for the concept, and TCP IP model we are using in the real networking scenario. Because nowadays we are not using OSI, we are using TCP IP. Are you getting my point, everyone? Yes or no?
Yes.
But concept is exactly same. Everything is same. Only one change is there. In in OSI model, how many layers you guys see here?
So,
7. But in TCP IP model, what are the layer? 1, 2, 3, and 4.
Four.
Because these 3 layers are useless now for network engineer. Yes or no? Tell me.
yes.
Yes, na? So what TCP IP will do? TCP IP merge all the 3 layers and convert only one layer, that is called application layer. Transport layer is known as transport layer. Network layer is called network layer. And TCP IP model convert or merge these data link layer and physical layer into one layer, that is called network access layer. So in TCP IP model, how many layers are there? Only 4 layers are there. That's the reason TCP IP model are more simple compared to OSI, because in OSI there are number of layers, but in case of TCP IP there are only 4 layers. So it is handy to use. Getting my point, everyone? Yes or no?
Yes.
See, TCP IP model is a set of rules that help computer to talk with each other over the internet. I already told you. Same OSI model. OSI model is also same now, everyone. Because of the OSI model, we can send or receive the data over the internet, and even any vendor can develop their device, develop their protocol by taking reference from OSI model. Getting my point? Same here in TCP/IP. TCP/IP stands for Transmission Control Protocol, or IP means Internet Protocol. These two are the main rules that makes your data and sent and receive properly. Now, again, one thing, who developed the TCP/IP? Please remember, US Department of Defense. Who? Department of Defense. US Department of Defense developed the TCP/IP around 1960. Are you clear, everyone? And it is the more simpler than OSI, because in OSI there are how many layers? 7. In TCP/IP only 4. Are you understand, everyone? Yes or no? This model has 4 layers, and each layer functionality is same as the OSI layer: application, transport, internet, and access. Clear, everyone? Tell me. Understand?
Yes, sir.
So there are, I mentioned here 3-4 differences. In OSI model, how many layers are there? 7. In TCP/IP, how many layers are there? 4. OSI model was developed by ISO, and TCP/IP is developed by DoD, Department of Defense. OSI model generally we are using for teaching and theoretical purpose, and TCP/IP we are using for real world scenario. Are you getting my point?
Yes.
OSI, we are handling it managed in multiple layers. Yes or no? In OSI model, you see na, and data link layer, and as well as transport layer, network layer. There we are concept of na error checking or error handling.
Yes.
Can you tell me yes or no?
Yes.
Guys,
Yes, sir.
see, this is the Ethernet header. In Ethernet header, there is a frame checksum. Yes or no?
Yes.
Okay.
Yes.
Now this is the layer number 3. At layer number 3 also there is a header checksum. Yes or no?
Yes. Also IP.
Layer
TCP.
number 4, there is also checksum. Yes or no? So
Yes.
it means in OSI model, there are multiple layer on which error handling is happening. But at TCP/IP only, there are which layer? Mainly
Transport.
TCP.
TCP.
Clear? So this is called, guys, OSI model and TCP/IP model. I hope you guys understand very well. Everyone. Tell me. Clear?
Yes, sir.
So this is all about the OSI model. Okay. Tomorrow we have a different topic.